You're here because you want to learn about Group 1 elements with a University of Cambridge graduate. This is actually part 2 of our periodic trends chapter. If you want to watch the previous videos or the future parts, be sure to check out our playlist below. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. So before we were talking about general periodic table properties and also general periodic trends as you go down the group or as you go across the period. Now we are going to focus more on a specific group, alright? And learn more in depth about the properties of elements in a very specific group. In this case, we will start with group 1, the alkali metals. So some properties to take note: your elements in this group 1 all have one valence electron each, okay? And they are chemically actually the most reactive metals. So these pure metals generally have to be stored in an inert liquid like paraffin oil, okay? It cannot be in contact with air and water, because otherwise it would get oxidized or it will just react with air or water, right? So you cannot store or retain the pure metal in that state. Then your elements also have similar physical properties. And please take note, this is important. You have to memorize this. These elements in group 1, right, they tend to be soft metallic solids, okay? And they have very low density, so much that you can actually find them to be floating on water, right? So your lithium, sodium, and potassium, these are all less dense than water. They also have low melting point, so it's actually very easy to melt them. And they are also good electrical conductors. Not surprising, because remember, recap from our chemical bonding chapter, metals tend to be good electrical conductors. And then you have high thermal conductivity for these metals. Again, not surprising, because these are all metals. In terms of chemical properties, these elements in group 1, okay, also share the same chemical properties. Again, this is linked to them having the same number of valence electrons. So they are all very reactive metals. They are also very strong reducing agents as well, right? Because they all readily lose one electron, okay, to form ions with a charge of 1+. These elements are also very known to react vigorously with cold water to form metal hydroxide and hydrogen gas. And it generally follows the equation over here, 2M plus 2H2O to give 2MOH plus H2, where M is the specific metal. So you can actually replace the M with the symbol of the group 1 element itself. Of course, nobody in the exam really uses M unless the question states so, right? And for example, I'll just give you an example over here. So lithium, for example, right? The equation of lithium reacting with water would be as such, right here. So you'll react with water to give lithium hydroxide and hydrogen gas. Your reactions also tend to be very exothermic with these group 1 elements itself. And the heat given off, okay, tends to ignite the hydrogen gas. So that's why they usually say that they react vigorously and could even cause a very violent explosion. And the reaction would become more vigorous as it goes down the group as well. Okay, remember, it's because the valence electron is further away from the nucleus as we move down the group. So your group 1 metals, right, tend to be more and more reactive down the group. Here I've given you a table that you absolutely have to go and memorize. These are all the reactions of your group 1 metals with water, right? So for example, lithium, this is a very fast reaction, and this is the equation as such, right? Your lithium will react with water to give lithium hydroxide and hydrogen gas, alright? Your sodium, okay, because it's further down the group compared to lithium, right? The reaction is actually faster. It's very fast, okay? It's important to use comparative words, alright? And sometimes you could even get an explosion. So your sodium will react with water to give sodium hydroxide and H2. Okay, remember, this is still following the base equation that I ran through just now. And then you have potassium, right? Potassium, you have an immediate explosion, kaboom, right? So your potassium will react with water, right, to give potassium hydroxide and hydrogen gas. So this, all right, is because your potassium is found even further down the group compared to lithium and compared to sodium as well. So that's why the reaction is more and more reactive. Your group 1 elements are also known to burn brightly, okay, when heated in chlorine gas to form a white solid. So your chlorine will react with these hot alkali metals, okay, to form solid ionic alkali metal chlorides. And it follows a basic equation of 2M plus Cl2 to give MCl, where M is a alkali metal. Actually, it should be 2MCl over here, right? And the reaction becomes more and more vigorous as you go down the group, which is not surprising. We already knew that for trends down the group 1, right? And all alkali metal chlorides are actually soluble in water. So here we also have a table that you absolutely have to memorize. Okay, take note, all tables here, you need to memorize all the content. So for metals, okay, they're reacting with chlorides, you will use this table. Lithium will burn in a bright flame, okay, and a white solid is produced, which is actually your lithium chloride. So your lithium will react with chlorine to give lithium chloride. Your sodium, right, will also burn in a bright flame and a white solid is produced, and the reaction is, well, seen to be more vigorous than lithium because sodium is further down in the group than lithium, right? So your sodium is going to react with chlorine to give sodium chloride, which is the white solid. Then you have potassium, right? This burns in a bright flame, the white solid is produced, and again, it is more rigorously reacting compared to sodium because potassium is lower in the group compared to sodium. Okay, so your potassium is going to react with chlorine and it's going to give you potassium chloride, which is also the white solid. Another property is when heated, your alkali metals readily burn in air to form basic oxides. So it follows this basic equation over here, 4M plus O2 to give 2M2O, where M is the alkali metal, right? So remember what I said, that your alkali metals, if you want to retain them in their pure form, you need to seal them in paraffin oil. They cannot be in contact with air or water. Okay, it's because of this. It cannot react with air here, right? Because it's normally very reactive with air. So the alkali metal oxides, okay, that are formed after that, okay, these will dissolve in water to form solutions of alkali, right? And of course, as I've said time and again, the reaction will get more and more vigorous down the group. So here are some example equations. For example, your sodium, okay, can react with oxygen to give sodium oxide. And then your sodium oxide can further react in water to give sodium hydroxide. Okay, your potassium will have a more vigorous reaction because potassium is lower in the group compared to sodium. Okay, it's going to react with oxygen to give potassium oxide. And then this potassium oxide is going to react with water to give potassium hydroxide. So you need to be very aware, okay, that these alkali metal oxides, right, like your sodium oxide and your potassium oxide, these can easily react with water to give an alkaline solution. Okay, so what trends do we see when we're actually going down the group as a whole? So in terms of physical properties, your melting point and your boiling point actually decreases. This is very commonly tested, by the way, so this is very important to memorize. Okay, this whole trend. Okay, and atomic radii also increases down the group. Why? Okay, because the number of electron shells increases down the group. And your densities increase as well. Okay, so all these trends are actually very important. And how about your chemical properties? In terms of chemical properties, right, your elements actually become more and more reactive down the group, as I've been saying, okay, and this actually makes them also stronger reducing agents as you go down the group. Okay, you can see from the examples that I ran through, they react more and more vigorously with either water or chlorine or air itself, right? And the elements lose valence electrons more easily to form positive ions because of the increase in the atomic radii or the number of electron shell. Okay, remember your valence, this is all because the valence electron, okay, is further from the nucleus. Okay, so it's easier to lose the valence electron. Alright, so it's very common for a question that's testing on periodic trends to ask you to predict the properties of other group 1 elements based off whatever information they give you, right? And you should be able to answer these questions based on whatever we just ran through. So the properties of these other elements, right, you can predict them from, okay, the known properties of lithium, sodium, and potassium. Okay, if you know it's in group 1, okay, they should share a lot of similar properties. Okay, and you should also know what are some of its properties based off the changes that we just ran through as you go down group 1, right? So for an example, the question might ask you, explain how rubidium, okay, would react with cold water. And what you'll do first is you'll find in the periodic table and you scan through, and you realize that rubidium is actually in group 1. Okay, so you know that this is related to your group 1 knowledge, okay, and they ask you to construct the equation for the reaction. So we know that your alkali metals tend to react with water, vigorously with water in fact, okay, and we remember the equation as well. Okay, we remember the equation is this simple equation over here, which is 2m plus 2H2O, right? And this will actually give you the hydroxide, which is 2MOH plus H2, right? So we know that it gives you the metal hydroxide at the end, right? So if you want to construct the equation, it should simply just be, for rubidium, it is 2Rb plus 2H2O to give 2RbOH plus H2, okay? And in terms of observations, right, we should know that your rubidium, okay, will react very vigorously with cold water, okay, and give a violent explosion immediately. Alright, so we know this because remember, our changes in group 1 indicate that as you go down the group, the element would react more and more vigorously either with water, chlorine, or air. So this is how we would predict, okay, in a question like this, what observation or what reaction would happen, okay, for an element in that particular group. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.